Welcome back to Operating Systems Crashcast. I'm Victor, and with me as always is the brilliant Sheila. Today we're diving into Chapter 5, Process Synchronization, starting with Section 5.1, Background. Sheila, why don't you give our listeners a quick overview of what this chapter is all about?
Absolutely, Victor. Chapter 5 is all about process synchronization, which is a crucial concept in operating systems. We'll be exploring how multiple processes can work together harmoniously, avoiding conflicts and ensuring data integrity. This chapter will cover various synchronization mechanisms and classic problems that illustrate the challenges of concurrent programming.
That's a great summary, Sheila. Now, let's focus on the background of process synchronization. Can you explain why synchronization is necessary in the first place?
Of course, Victor. Imagine a scenario where multiple processes are running concurrently on a system. These processes often need to share data or resources. Without proper synchronization, we can run into serious problems. Think of it like multiple people trying to access and modify a shared bank account simultaneously. Chaos could ensue if their actions aren't coordinated.
That's an excellent analogy, Sheila. So what kind of issues can arise from this lack of synchronization?
The main issue we encounter is what we call a race condition. This occurs when multiple processes access and manipulate shared data concurrently, and the outcome depends on the particular order in which the access takes place. If this order is not managed correctly, it can lead to inconsistent or corrupt data.
I see. Can you give our listeners a concrete example of a race condition?
Certainly. Let's stick with our bank account analogy. Imagine two processes simultaneously trying to withdraw money from an account with a balance of $1,000. Process A checks the balance, sees that there's enough money, and starts to withdraw $800. At the same time, Process B also checks the balance, sees $1,000, and initiates a withdrawal of $500. If not properly synchronized, both withdrawals might succeed, leaving the account with a negative balance. Clearly not what we want.
That's a great example, Sheila. It really highlights the importance of maintaining data consistency. So, how does process synchronization address these issues?
Process synchronization provides mechanisms to coordinate the execution of multiple processes, ensuring that they access shared data in a controlled manner. It helps maintain the consistency and integrity of shared resources by preventing race conditions and other concurrency-related problems.
Excellent explanation. Now, I'm curious about the historical context. When did process synchronization become a significant concern in operating systems?
Great question, Victor. Process synchronization became a critical concern with the advent of multi-programming and time-sharing systems in the 1960s. As computers began to handle multiple processes concurrently, the need for coordination between these processes became apparent. Early operating systems like Multics and Unix incorporated synchronization primitives to address these challenges.
That's fascinating, Sheila. It's amazing how these concepts developed alongside the evolution of computing systems. Now, for our listeners who might be preparing for interviews, what would you say are the key takeaways from this background on process synchronization?
For interviews, I'd emphasize these points. 1. Process synchronization is essential for maintaining data consistency in concurrent systems. 2. Race conditions are a primary concern, occurring when multiple processes access shared data simultaneously. 3. Without proper synchronization, systems can produce incorrect results or corrupt data. 4. Synchronization mechanisms coordinate process execution to ensure safe access to shared resources. 5. Understanding synchronization is crucial for developing reliable and efficient multi-process systems.
Excellent summary, Sheila. As we wrap up this episode, it's clear that process synchronization is a fundamental concept in operating systems. It's not just a theoretical concern. It has real-world implications for system reliability and data integrity. In our next episode, we'll delve deeper into specific synchronization mechanisms and how they address these challenges.
Absolutely, Victor. Understanding the background and importance of process synchronization sets the stage for exploring more advanced concepts. It's a fascinating area that continues to be relevant in modern computing. from multi-core processors to distributed systems.
Thank you, Sheila, for your insights. And thank you, listeners, for tuning in to Operating Systems Crashcast. Join us next time as we continue our journey through the intricacies of process synchronization. Until then, keep your processes in sync and your data consistent.